Hi everybody, it's Mr. Gray here. I want to talk about our fraction celebration of knowledge, and this is really about setting the foundation for what fractions are. As we get into 4th grade and 5th grade, and then in 6th grade, we start manipulating the fractions with addition, subtraction, multiplication, in 6th grade division of fractions, and also ratio thinking. But understanding kind of conceptually what a fraction is, its relationship to division, are all things that we're kind of setting the stage for here in 3rd grade. So this is the question is number 1. 6 friends divide 3 apples equally. How many apples does each friend get? Draw a model or show your work. Now, some students are going to be able to see that relationship between 3 and 6 pretty quickly, but we're really trying to give this idea of having to show your work to see what your thinking is, because that really becomes even more important than the answer sometimes, is being able to communicate that thinking. So we have a phrase in class, if you can't show it, you don't know it. So there has to be a way to show that. So there's different ways to show it, but if I have 3 apples, I could just represent the 3 apples with 3 boxes. There's my 3 apples right there. And if 6 friends get an equal amount, I can split them. And then I have, friend 1, friend 2, friend 3, friend 4, friend 5, friend 6. So to figure out how much that is, I'm just going to zoom in on 1 apple. And, each friend is going to get that much, which is half an apple. So again, there's different ways to show that, but ultimately the answer is each friend gets half an apple. Number 2, 8 sisters divide 2 brownies equally. How many brownies does each sister get? Hopefully they're big ones to avoid big fights. But if I have 2 brownies, okay, 2 brownies, and I need to make 8 pieces total, I could have 4 pieces in this one and 4 pieces in that one. And then each sister, kind of similar to above, each sister is just going to get 1 of those pieces because now I have 8 pieces. Another way to write that, maybe some students will write it like this, one of the brownies will be in 4 pieces like that. That's another way to write it. So you'll see different models, but either way, each sister is going to get 1/4 of a brownie. And that's the answer to that one. What does the fraction 3/4 mean? You can use words, models, and number lines. So, in an ideal world, we're getting to this idea where the denominator for this denominator right here is how many pieces something was split into. So the denominator tells us how many pieces it was split into, and the numerator right there tells us how many pieces I'm focusing in on or will be shaded in. So the kids might use like a drawing. They might show you that 3/4 counts for that much. Ideally it would be a sentence where they would say 3/4 means I split something up into 4 equal pieces and I'm focused in, or the shaded part, or the part that's important is 3 of the pieces. And so that you might see number lines, you might see models as they're trying to explain, but some kind of representation like that this could be the 3/4 right there. So something along those lines are what we're looking for. What fraction is represented by the shaded part? Write the fraction represented by the shaded part. So I have 1, 2, 3, 4, 5, 6, 7, 8 equal pieces, and 2 of them are shaded. So I have 2 out of 8, and of course, that's what we're looking for right now. Later on, we want kids to simplify fractions, and we got into a little bit of what equivalent fractions are. So if your student wrote 1/4, that's also perfectly acceptable, because if I zoom in on just one part, 1 out of 4 is shaded, and that's true for both of those parts. So 2/8 or 1/4 are great on those ones. Write the fraction that names the point. The easiest way for the kids to do this one, what we practiced a lot in class, was I can count how many pieces there are. So point A is just one piece of how many. So it's one piece of how many? Well, there's 1, 2, 3, 4, 5, 6 pieces. So it's 1/6. Now that would help me on the other ones. The other thing that happens sometimes with students is they will count this as 1. They'll start their counting here, and they'll go 1, 2, 3, 4, 5, 6, 7. So if you see 1/7, that's how they got that one. Okay, but the first one is 1/6. If I know that, I just jump one more, so that's 2/6 is point B. And then from the end, I know that 1 is 6 out of 6. So if I go 1 back, it's only going to be 5 out of 6. Okay, number 6, we're using greater than, less than, or equal to compare these. And so there's different ways that kids can think about this. The first one right here, 1/4 and 1/2, a lot of times we would actually draw these out and we would look. So I have 1/4 right here and 1/2. The 1/2 is more. I could also think of it in a number line. So I have 0 and 1, 1/2's right in the middle, 1/4's a little less. So there's 1/4, but that is 1/2. So 1/2 is bigger. A shortcut would be, I know that if this is smaller, if the denominator is smaller, the pieces are bigger. So if I only have one piece of each, then the smaller denominator is going to be bigger. 1/4 and 2/8, that one is going to be a tricky one. A lot of kids will look at the denominators and say, oh, this denominator is bigger, so it must be like that. They might say, oh, the numerator is bigger, so it must be like that. But in reality, what we're looking for is the kids being able to see that 1/4, just like that, is the same as if I did 2/8. Like this piece right here is the same size piece as that right there. So these are equal. 5/5 and 4/5. I think many kids are going to see that one, that 5/5 is greater because it's easy to compare them with the same denominator. And then 3/4 and 3/8. Again, they could draw models, but if they have the same number of pieces, so if I have 3/4 right here, and I have 3/8, hopefully I'm going to see that 3/4 really covers a much bigger area of that model. So 3/4 is bigger. There you go. Use the model to find 1/3 of 12. So again, there's different ways the kids could do this. Hopefully they're going to be able to cut it up in some way. So the easiest way for them to see it is that I have 3 equal pieces, 1, 2, 3, and I'm only focusing on 1 out of the 3 equal pieces. So 1/3 of 12 is 4. Circle all the fractions equivalent to 1/4. We did this in 3 ways. The first way was drawing a model. So we were able to do 1/4 and see it as that. And then we were maybe able to even compare it and go, well, I could make this 8ths, and I see that my 2/8 is the exact same as 1/4. We can see it right there. So we know that 2/8 is equivalent. 2/4 is not equivalent. I can see it in the model. Hopefully we see that 4/1 is not equivalent. 1/2, so maybe for this one, maybe the kids used a number line. And so just like I showed you before, I can make 1/2 right in the middle, and I might know that 1/4 is right there because I can split it into 4 pieces. So those are not equivalent. And then maybe the same with 1/8. I can look at the models again. So those were the kind of 3 ways, the 2 ways we thought about it. The other one was, if students were ready for another way of looking at it. Not everyone got to this point, but some students saw this relationship that if I could multiply the numerator and denominator by the same number, if this number is the same, then these fractions are equivalent. So if I take 1/4 and I multiply both the numerator and the denominator by 3, get 3/12, these must be equivalent because the numerator and denominator are multiplied by the same number. Again, not every student got to that or saw that, and that is just fine. Hopefully they're able to see it with models. But this kind of thinking sets the stage for addition, subtraction later on. But seeing equivalent fractions is what we're looking for. Right now, circle all the fractions equivalent to 1/2. Same kind of thing. I have different ways to look at it, but 2/4 is equivalent, 1/3 is not equivalent, 3/6 is equivalent, and 4/8 is equivalent. So those are tough ones, but those are great ones. Draw a model to show that 3/4 is equal to 6/8. I could do that with circles. I bet a lot of students are going to have maybe circles like this, and they might show it on 1 or they might show it with 2. So if they show it on 1, they're going to have something that looks like that. and then maybe they write over it. And they go, okay, well, I'm going to make 6/8, and I have 1, 2, 3, 4, 5, 6, and it's the same amount. Okay, if they show 2 of them, they're going to take the first one, and they're going to color in 6/8, and they're going to have the second circle, and they're going to make 8. There we go. They're going to make 8, and they're going to have the 6/8 colored in, and you're going to be able to see that this is the same as that. So we're going to see those are the same amount. So any kind of model, they also might do it on a number line. So they might make 2 number lines or 1 number line and show that 3/4 and 6/8 are in the same place. So I could do 3/4 right there, and then if I split those again, I would have 6/8 looking that way. So those would be the different ways they could show that. Miss Patterson owns 4 parakeets. 1/5 of her birds are parakeets. How many birds does Miss Patterson own? So this is a tough one. The kids might think I have to take 4 and split it 5 ways, but it's actually opposite. So there's 4 parakeets. There's 4 parakeets, but that makes up 1/5 of the birds. That makes up 1 out of 5 of the birds. So in total, you know, Mrs. Patterson's is just these ones right here. And so in total, there are 20 birds. Okay? For each number line, write the fraction that fits with the question mark. So this goes back to some of the things we were talking before, but the kids often are going to see that this is broken up into 1, 2 pieces, which makes up the denominator, but I'm only counting 1 of the pieces. That's 1/2. Same thing down here. 1, 2, 3, 4 out of 5, 6 pieces. Okay, and of course we would accept 2/3 also. This one is 1, 2 out of 3, 4, 5, 6, 7, 8. 2 out of 8, and of course we would accept 1/4 also.